This video presents our work demonstrating a new beam steerable antenna for applications in 5G base stations. After severe congestions noted in the present sub 3 GHz band, millimeter wave bands are being extensively explored for 5G network. To deal with issues like atmospheric attenuation and path loss, beamforming and beam steering is considered as one of the key enablers for the technology, and hence here we focus on a leaky wave architecture based slot array antenna developed on a new corrugated SIW. Conventional SIWs have multiple wires running through the guiding structure, making it difficult to put active components, which are then replaced with inductive stubs in corrugated SIW. Here, these corrugations in a conventional CSIW are replaced with Inter-Digitated Capacitor. It presents a lower transmission loss of 0.7 dB compared to a conventional CSIW, which has a loss greater than 1.5 dB. Please note that the proposed IDC-CSIW only works for TE10 mode, same as a conventional CSIW. The performance of such IDC-CSIW is then verified using an equivalent circuit. A mathematical equation has been derived to calculate the cutoff frequency of such waveguide structures. It is derived using two components, that is, the cutoff frequency of an SIW of same width and the bandpass functionality that the IDC-CSIW presents. The validity of the equation has been confirmed with parametric analysis. This IDC-CSIW is used to create a 6-element slot array antenna. Pin diodes are placed within the corrugation, which allows the manipulation of surface current. The antenna is fed from both ends and is controlled using an SPDT switch. Here we can see the fabricated antenna with 30 pin diodes controlling the antenna. A set of 5 pin diodes are controlled simultaneously and is biased using the biasing line. The antenna was first measured with no biasings on the pin diodes. Here we can see the S11 for 2 feeds, and the antenna is working at 26 to 29 GHz band and has a very good match with simulated results. For each feed, the antenna has 2 beams pointing in 2 different directions because of the two different points of feeds. It has a total efficiency greater than 70% and a gain larger than 12 dpi. Pin diodes are used to control the beam direction. As shown earlier, a set of 5 pin diodes are controlled simultaneously, and here it is called a unit cell. This set of 5 pin diodes, when forward biased, it manipulates the surface current in a selective area and moves the signal towards the U-shaped slot created within the corrugations. This forward biasing allows for the change in beam direction and hence provides beam steering based on different corrugations of pin diodes. Here we can see a continuous beam steer between plus 60 degrees and minus 60 degrees in azimuth plane with an approximately stable gain of 13.5 dB. However, since the antenna is fed from 2 different sides, the beam gets split in 2 halves in the elevation plane, hence giving us a break in the continuous steering. This is resolved with 2-element array. 2 of such antennas are placed together as a mirror image and are fed from 4 corners using an SP4T switch. Here a 2.4 mm connector was used to feed the antenna, and male header pins were used to control the biasing paths for pin diodes and switches. The measured S parameters had a good agreement with simulation, showing the same 26 to 29 GHz frequency band, and based on which feed point is used, the antenna provided a full 120-degree beam steer in azimuth plane and a 30-degree beam steer in the elevation plane. To summarize, we have presented an integrated digitated capacitor based corrugated SIW, which is then used for a leaky wave architecture for a 6-element slot array, which is operating at 26 to 29 GHz frequency band and has a beam steering range of 120 degrees in azimuth plane and 30 degrees in elevation plane. The size of the antenna is very small, which is 75 by 22.4 mm, and it has side lobe levels greater than 15 dB. Thank you.